The Bohr theory explained some observations, such as the spectrum of the hydrogen atom, but it could not explain the spectra of other atoms. A new model, the quantum mechanical model, was more successful in this respect. The model was developed by Erwin Schrödinger and Max Born. Instead of treating the electron as a particle moving in orbits, Schrödinger described it in terms of a mathematical formula called a wave function. Born defined the wave function as a probability of finding the electron in a given volume outside the nucleus. Simplifying greatly, quantum theory describes a volume in space in which the probability of finding the electron is very high. The space in which the electron moves about is called the electron cloud. You might help your students understand this better by using this analogy. When an electric fan is at rest, you know exactly how many blades there are and where they are. When the blades start turning, you seem to see more than 3 blades. At full speed, all you see is a blur. You cannot say exactly where each blade is, but you know that there are 3 blades there. This is how we might imagine the electron cloud. For the hydrogen atom, the shape of the electron cloud is spherical. The single electron of hydrogen travels around the nucleus within this sphere. This sphere, or electron cloud, is also known as the atomic orbital of hydrogen. The atom, described this way, is deceptively simple. However, as we go on to other atoms, the atomic orbitals begin to look more complicated. Chemists use both the quantum mechanical and the Bohr models to understand and explain the properties of matter. Chemical changes and nuclear transformations can also be understood in terms of electrons, protons, and neutrons. The quark theory of modern physics goes further than that. In this theory, protons and neutrons are made of smaller particles called quarks. The electron is still a fundamental particle, hundreds of subatomic, one of 3 types of leptons. Hundreds of subatomic particles are also presumed to exist.